All right, 11.2, I stopped doing a bunch of the notes on here. It's still notes. It's just more of examples than it is fill in the blank notes, just so you guys know. So it'll move a little bit quicker. But 11.2 are for inferences and two-way tables, and this is a very long section, so it'll probably take us a couple days to do it. I know we will not finish it today. Probably today, tomorrow, and maybe a little bit of Monday. And then 12.1 I think is short as well. And then I want to try to test by next Thursday and have it done, and then start reviewing for your AP exam when we come back from break. Got it? Okay. Second? Yeah. Friday to Friday. We can come back the following Monday. Good. Okay, we were just answering. All right. So comparing conditional distributions, it says market researchers suspect that background music may affect the mood and buying behavior of customers. One study in a European restaurant compared 3 randomly assigned treatments: no music, French accordion music, and Italian string music. Under each condition, the researchers recorded the number of customers who ordered French, Italian, and other entrees. Here's the table that summarizes the data. So while they were eating, they played one specific song, and they were trying to see if it would affect what you actually ordered off the menu. So would French music make you want to eat French food? Does that make sense? All right. So the first thing says calculate the conditional distribution in proportions of entrees ordered for each treatment. So we're going to start with French entree ordered, and then no music. So this number right here. The way that we do that is we do 30 over 84. And we've done conditional tables before, so this is not new. This gives you 0.357. Keep going across. French entree with French music. Is 39. Over the total would be 75, which gives you 0.520. And the last one is, this is the last one in this category, French entree and Italian music. And if you need to write that this is the entree and this is the music, that's fine. Which has 30 over 84 again. So 30 here over the total 84, which is 0.357. I'm going to move to the Italian entree with no music. What would I do on that one? Perfect. That gives me 0.131. Italian entree, French music. What would I do on that one? Which gives you 0.013. And then Italian. Hold on. Say what? Yep. Which gives you, I think it's 0.226. Can't even read my writing. Yeah. And then we're going to go to other entree and no music, which will be 43 over 84, or 0.512. Other and French music would be 35 over 75. Other and Italian, 35 over 84.417. All right, so B says make an appropriate graph for comparing the conditional distribution. So that would be a bar graph, and we're going to make one a little bit later, but just make sure that you label everything. And I'm not going to make you do it on this one, but we'll do it on a different one. Okay, so it's a little bit less that you have to graph. So we'll go back to B. It's a bar graph. It's nothing hard. So part C says write a few sentences comparing the distributions of entrees ordered under the 3 music treatments. So just tell me, and you don't have to look at these. You can look at the other ones. It doesn't matter. What do you notice? What do you notice? Yeah, so French entrees, hold on just one second. For French entrees, if French music was playing, the majority of the people wanted French food, right? What about for Italian? Same thing. And for other, what about that one? It was kind of split, so it didn't really matter what they ordered, right? Does everybody understand that? That's all you have to write. We're not gonna, you can write it if you want to. I'm not gonna write it down. The conditional itself is really what we needed. Flip it over. We're going to do the same thing, and this is the one that we're actually going to do the bar graph on because you have plenty of room to do it. All right. So the Pennsylvania State University has its main campus in the town of State College and more than 20 smaller Commonwealth campuses around the state. The Penn State Division of Student Affairs polls separate random samples of undergrads from the main campus and Commonwealth campuses about their use of the online social networking. Facebook was the most popular site with more than 80% of students having an account. Here's a comparison of Facebook use by undergraduates at the main campus and Commonwealth campuses who have a Facebook account. So calculate the conditional distribution and proportions of Facebook use for each campus setting. So we're going to do it for each campus setting. So that means we're going to do it for Maine, and we're going to do it for Commonwealth. We're going to do Maine for several times a month or less. So how would I do that one? How would I find the proportion for that one? Main campus, several times a month or less. 55 over 910, which is 0.06. At least once a week. How would we do that one? That gives you 2.36. I'm sorry, 0.236. And then for the day, finish that up with 640 over 910, which is 0.703. For Commonwealth, you're going to do the same thing. So for several, what would it be? 0.121. The next one is a 0.250. And the last one is 0.628. Why do you think it's important to compare proportions rather than count in question 1?
Isn't it kind of like standardizing, so it works with the formulas?
Say it one more time, Kyle. I'm sorry, I had you turned down.
It's like how you standardize, so it works with the formulas.
Not necessarily, but you're kind of close. Why do we standardize? Say it again. Yeah, if you're looking at the curve, you can see it with the same scale, right? So when we're looking at this, look at our two populations. Y'all see that? So think about it in terms of money. If everybody gave $1, this group had 100% participation, but how much money would they have? If everybody gave $1. Okay. And this group? But they all gave, right? So this is like comparing apples to oranges. So we turn it into percentages so that we compare on the same scale. Does that make sense? So the reason that we do that is there's such a difference in the sample sizes. But you are correct. It is just like standardizing. And then 3, I'm going to make a really rough graph. And again, the reason I chose this one is because it only has two things that you're comparing, the main campus and the Commonwealth, rather than the 3 things from the other one. So this is what it's going to look like. I'm going to make an L graph. I'm going to put it up there. Hold on. This is going to be your percent on the campus. If we were doing the other one, it would be French, Italian, and other, and you would have to do each category in them. So on this one, we're doing Maine and the Commonwealth campus. And there are 3 categories in each. There are several times, once a week, and at least once a day. Okay. So I'm going to label them S for several. So if we look at Maine campus, it was 0.06 or 6%. Then we have once a week was 23.6%. And again, try to make your bars the same width, but mine are not right now. And then we have a day was 70.3%. So pretty much all the way up. And then you do the same thing with the Commonwealth. So the Commonwealth for several was 12%. For the week was 25%. And then for the day was 62.8. And that's how you make your bar graph. So the second part of that said, what are the most important differences in Facebook use between the 2 campus settings? Well, there's a difference. Look at these. Compare these side by side. Just tell me about them. Yeah, okay. Main campus has more daily use. Okay. What else? What about Commonwealth? Several times a month or less. Just super class discussion right here. Why do you think that's the case? Why do you think that might be the case? Say what? Maybe. Y'all ever, you know how they do like satellite campuses? What are your satellite campuses usually for? Older people, right? So how much will they use Facebook? Does that make sense? So your main campus is usually going to be like where you guys are going to be in the next year, year and a half, 2 years, whatever. So that main campus is where you house those younger students. So they're probably going to be on social media sites more. Your satellite campuses are usually like your graduates or even like night classes, things like that, where older people are going to. Does that make sense? All right, very good. Look at your next one. When we're computing expected counts, again, we're still doing the background music influencing customers. The null hypothesis in the restaurant is that there's no difference in the distribution of entrees ordered when no music, French, accordion music, or Italian music is played. To find the expected counts, we start by assuming H sub O is true. And again, H sub O is that there's no difference, like they just order whatever regardless. We can see from the two-way table that 99 out of the 243 entrees ordered during the study were French. So it's the same table. There's nothing crazy. All they did was add these totals on the end, so we didn't have these a minute ago. If a specific type of music that's playing has no effect on entree orders, the proportion of French entrees ordered under each music condition should be 99 out of 243. Which equals 0.4074. For instance, there were 84 total entrees ordered when no music was playing. So then we would expect 84 times 0.4074 or 34.22 entrees. So we're just taking the percentage of the whole. So we would expect 34.22 of those entrees to be French on average. The expected counts of French entrees ordered under the other two music conditions can be found in a similar way. So French music would be 70 times 75 times that same proportion, which gives you 30.56. And then Italian music, there were 84 of those times 0.4074 or 34.22. We repeat the process to find the expected count for the other two types of entrees. The overall proportion of Italian entrees ordered during the study was 0.1276. So the expected counts of the other entrees ordered for each treatment are, and we have the expected counts on the next table, so I'm gonna go put those in, okay? This is where you would work them out. We're not gonna work them out, but they're on the other table. So the following table summarizes the expected counts for all three treatments. Note that the values for no music and Italian music are the same because 84 total entrees were ordered under each condition. We can check our work by adding the expected count to obtain the row and column totals as in the table. These should be the same as those in the table of observed counts, except for the small round off errors such as 75.01 rather than just 75 for the total number of French entrees ordered. Okay. So we did French with French music, French with Italian music, and French with no music, right? So I remember that. All right, so those were right here, 34.22 for no music, 30.56 for French music, and 34.22. All right, so one more time, let me show you where all this came from. So when we did our first proportion, our 34.22, the way we got it was we did the 99, 243. That came from right here, 99 out of 243 total. Does that make sense? Everybody good? That's where we got our 0.4074. This is on that other page. I'm just rewriting it down so you guys can see it. Then we did 84 times that proportion. That 84 came from right here. Everybody see that? When you multiply it by that proportion, you get the 34.22. So how do we do Italian? Which gives us 0.128. Everybody okay with that? So how do we find this value right here? This Italian with no music. Which gives us, I have 7.5, they have 7.2. I think they rounded a little bit more on this. They probably kept it as 31 over 243. Okay. So these numbers might be off just a little bit. I'm gonna go with what's in there. So I just wanted you to know how I got those numbers. I'm not gonna make you calculate them all. When you do 75 times that 31 over 243, you get 9.57. And then remember, this column is going to match because it's also 84. So then to get your last one, you're going to do that 113 over 243, and you get 0.465. So you're going to multiply 84 times 0.465, and you get 39.06, which is going to be the same as the last column. And then you do 75 times that same proportion and you get 34.88. Now, what they're saying is you can check your solutions, okay? You can check your expected counts, and you do that by just adding a column. And it should be really close to 84, and this one actually adds exactly to 84. Got it? You might be off. It might be 34.01 or something like that, and that's okay. Or sorry, 84.01. That's from your rounding. So it just depends on how you round. Got it? Everybody good? Same thing the other way. If you go across 34.22 plus 30.56 plus 34.22 should give you that 99. Got it? Everybody good? So make sure you check that when you do it. So finding expected counts when H sub O is true. The expected count in any cell of a two-way table is This is the formula for expected count. The row total times the column total over the table total. Don't forget your conditions for performing a chi-square test for homogeneity. This is the same. Everything happens the same. And what was our large counts this time? At least 5. All right, so the tables below show the observed and expected counts for restaurants. The restaurant experiment, calculate the chi-square statistic and show your work. So these are all those values that we've already had. This is the one we got in the beginning. This is the one that we just calculated. So how do we calculate the chi-square statistic? Here's what you're going to do. You're going to go into your calculator on second and X1. Do you guys know how to put matrices in? You do? Okay, so we're going to go in our matrix and we're going to edit. So second matrix, we're going to go over to edit. It's row by column. I had 3 rows and 3 columns. The total columns do not count. The total row and columns do not count. It's just what's inside. So this part right here, it's going to be a 3 by 3. So when you edit 3 by 3, you're going to type them in just like you see them, and it goes across. So 30, 39, 30, 11, 1, 19, 43, 35, 35. And again, we just put in the observed. You're going to do it again. So second matrix edit. And that's all I'm writing down. Second matrix edit. And you're going to do the expected. Go to B. It's also a 3 by 3. And we're going to put that in 34.22, 30.56, 34.22, 10.72. 39.06, 34.88, 39.06. Everybody good? You're going to go into stats, over to test, and not the GOF test, the chi-square test. So letter C. You will see that we put observed in A, expected in B, and you calculate it, and it tells you exactly what it is. You want to write all 3 of those things down. All it asked for this time was just your chi-square statistic, but when we do this, it's giving you your p-value. Why do you think it gives you your p-value? So you can test against alpha. Everybody see that? And then remember, we always write our degrees of freedom down. So for this, I'm gonna move my calculator over so I can write. Your chi-square is 18.28. We're gonna go ahead and write our p-value 0.01 and our degrees of freedom are 4. And I will show you later how to get your degrees of freedom. Stay right here. This is on the calculator. How do you do this by hand? We already talked about this. Observed, not expected. So, so we would start with this one. This is ridiculous to do. I'm going to do a couple of them just to remind you what the formula is, and then go from there. So the observed, minus the expected squared over the expected. So this would be 30 minus 34.22 squared over 34.22. It does not matter what order you go in. I just always go across. My observed was 39. My expected was 30.56 squared over 30.56. And across the top again, 30 minus 34.22 squared over 34.22. You would go to the next row, 11 minus 10.72 squared over 10.72 square, or sorry, just 72. And then you would keep going on that row and then you drop down to the third row. It's absolutely ridiculous, but you're still gonna get 18.28. How do you find your degrees of freedom? You do the number of rows minus 1, number of columns minus 1, and you multiply those together. Row goes horizontal, column goes up and down. In this case right now, it doesn't matter because it's a 3 by 3. Think about columns. What do columns look like? Up and down. All right. So it's a 3 by 3. So it's 3 minus 1 times 3 minus 1, or 2 times 2, which is 4. That's where this degrees of freedom comes from. I have this next page and I want to be done. So front and back of the next page and then we'll be done. That's exactly where I wanted to get to. Perfect. All right. Any questions on this part? I would suggest that you use your calculator, but make sure that you write everything down, okay? All right. Finding the p-value in the conclusion, I just showed you how to find the p-value in your calculator. You can find it by hand. I will show you how to do that as well. You just keep using the calculator. All right, so earlier we stated a significance test of, and I'm going to shorten these, H sub O means that there is no difference. That means no difference in playing the music while ordering the entree. It doesn't make a difference to play the music. It doesn't affect the ordering. And then there is no difference, or there is a difference for your alternate. All right, so there's a big gap there. Don't worry about it. It's just jacked up. I don't know why. We already checked that the conditions are met and our calculated test statistic was 18.28. We just did that. So it says use table C to find the p-value. So we did that yesterday, not yesterday, but the day before. Okay, so remember how we do that. When we look at table C, we first look for our degrees of freedom. So how many degrees of freedom do we have? 4. And then what was our statistic? So we look for 18.28, and it falls between this 16 and this 18, which is between 0.0025 and this is 0.001. That's it. So that's what you write, between 0.0025 and 0.001. So A, to do table C, did I say 0.025? Sorry. Yep. And 0.001. But then look at the second part. It says use your calculators, and this should say chi-squared CDF command. So how do I do that? Where's that at? Where's every other CDF command? Not just bars, but second bars. Right. So remember that this value is on which side? The right side. So when we make our curve, it looks like this. So what would be my lower? Mm-hmm. What's my upper? Really big number. And my degrees of freedom were 4. And when we put that in, we get a p-value of 0.0010. So 0.001. Now remember that value that was underneath 0.001 was 18.48. So it should be really close to that anyway. Okay. B, how do we interpret the p-value? You did this on your test. I'm not sure why you're not talking. Y'all don't know how to interpret p-value? Sure. Okay, the only thing that you need to remember, and most of you did it when you did your test, and I don't think I counted off for this time, but this right here. Assuming there is no difference. Mm-hmm. There is a 0.001 probability of observing, sorry. Good gracious. A difference in the distribution of entrees as large or larger than the one in this study. I think you guys gave the value. That's fine. It doesn't matter, but you don't have to put that. Right. So what conclusion can we draw? How do we draw a conclusion? The p-value to the alpha, the p-value is 0.001. We didn't state an alpha, so 0.05. So what do we know? So we reject H sub O, which means there is a difference. And you would go all the way back to the one that we started with. That there is a difference in the number of customers who order French Italian or other entrees based on the music or whatever. It doesn't matter. Okay. Back of this page and we're done. Ooh, sorry, y'all. All right. In the previous Check Your Understanding, page 699, we presented the data on the use of Facebook by 2 randomly selected groups of Penn State students. Here's the data once again. Do these data provide convincing evidence of a difference in the distributions of Facebook use among the students in the 2 campus settings? So the first one, state appropriate null and alternative hypotheses for a significance test to help answer the question. So what's your null hypothesis? Say it again. No difference. And you guys don't have to be specific. There's no difference in the distribution of Facebook use among students in the two campus settings. What's your alternative? There is a difference. Calculate the expected counts and show your work. Calculate the expected counts and show your work. How would we do that? Remember what it said. What was the easiest way to do it? Yeah, go back. What's it say? Row total, column total, table total. Right? Let's start with this one. Start with this one. How would we do this one? What's your row total? Do what? It's 131. The next one is going to be 372. All I wanted you to do is be able to tell me that you needed to add them up. 1034 and 1537. So this is your table total right here. So start with main campus several times a month or less. What would be my expected counts? How would I do that? I'm going to go with the formula. Row total would be 131. Column total would be 910. Doesn't matter what order you do it in. Okay. Table total is 1537, which gives us 77.56. To do the next one, what are we going to do? I'm on this one. It's okay. I was trying to figure out where y'all were. Six, 2, 7, 1537. And that's going to give you 53.44. You guys good with that? Do I need to show you all of them? Okay. The next one here is going to be 220.25. Keep going down, 612.19. Across 151.75 and 421.81. So the reason I wrote them up there is so that you can see them side by side, but we're going to have to put them into our calculator as a table. So I wanted to put them together, so I wasn't flipping back and forth. Calculate the chi-square. It says show your work. If it says show your work, you're doing the formula. It's not doing it in the calculator, but we're going to do it in the calculator. So how do you do that in the calculator? Oh, sorry. We're going to edit. If you're not sure what it is, type it in. And if it doesn't look like your table, then you know you put them in wrong. Your dimensions wrong. Got it? But it's row by column. All right. So then our first matrix is going to be the one that they gave us or observed. 55, 76, 215, 157, 640, and 394. We're going to do the same thing again. We're going to edit B. It's also a 3 by 2. And we're going to have 77.56, 53.44, 220.25, 151.75, 612.19, and 421.81. What do we do now? Mhm. We have A and B, and we can calculate. And we get that our chi-squared is 19.49. P is gonna be, watch this, you get, some of you on your test still miss this. If it's E -5, I'm putting 4 zeros in front of it. And then degrees of freedom were 2. How did I how do I do that by hand, degrees of freedom? There were 3 rows -1, 2 columns -1, gives me 2 times 1 or 2. Okay, just so you have that. Use table C to find the p-value. You guys okay with finding that? Yes. Look for degrees of freedom of 2 and then find the 19.49 and it'll be between 2 numbers. Okay. Then use your calculators. We found that. So this is number 4. Number 5 is interpret the p-value in context. So interpret this p-value. Mm-hmm. Mm-hmm. Why can I not write that word? Of obtaining a sample as large or larger than the study. And then the last thing that we're doing is what conclusion would you draw? Your p-value is essentially 0. Your alpha level that they didn't give you is going to be 0.05. So we know that it's less. So we do what? Reject H sub O, which means we have convincing evidence that there is a difference. Any questions? All right, on the next page, we're not going to the next page. That first box was already done. Okay, because we already did the two-way tables in the calculator. So tomorrow we'll start at the chi-square test for homogeneity. Good. All right. You will not have any homework tonight. Yeah, you're welcome. All right, you guys can go ahead and